All right, here's solutions for perfect problem 6 for Math 251. You're taking some derivatives, I guess 3 derivatives of this function f of x equals x to the x. So for part 1, you're just trying to find the derivative, and the trick to do this is to use logarithmic differentiation. So to do that, you have to set this up as an equation, and your idea is you want to try to find y prime. And you can't take the derivative of both sides of the equation, but what you could do is take the log of both sides of the equation. What that would allow you to do is apply one of your log rules here. You can bring that x down in front. And by doing all this algebra, we've gotten things to the point where we're able to take the derivative of both sides of the equation. So the derivative natural log of y is 1 over y times y prime. That's a chain rule there. And then on the right here, I guess we'd use the product rule. So f prime, which is 1, times g, which is the natural log of x, plus g prime, which is 1 over x, times f, which is just x. So I guess I could simplify this side. 1 over x times x is just 1. So really I got 1 plus the natural log of x on this side. And on this side I have kind of y prime over y, I guess. And so therefore y prime is equal to y times this thing, but y is equal to x to the x. So I get this, which I think is exactly what I was trying to come up with. And then for the second derivative, to find the second derivative, what I'm going to do is, again, set this up using logarithmic differentiation. So maybe I'll say, okay, y prime equals x to the x times 1 plus the natural log of x. And again, I can't take the derivative of both sides, but I could take the natural log of both sides. So that I could apply some log rules. So I'll leave this side alone for now. And on this side, I'll first apply what I refer to as the first log rule. That says the log of a product is equal to the sum of those logs. So instead of the log of this times this, I have the log of this plus the log of this. And now I can use my what I call the third log rule to take this exponent down in front of my natural log. To get something that looks like this. And so now finally I can do some calculus. I can take the derivative of both sides of the equation. I get 1 over y 1 over y prime times y double prime. And that's equal to, let's see, I need the derivative of x times the natural log of x. I figured that out earlier right here. Right, it's equal to this thing, which was equal to this thing. So I got 1 plus natural log of x is the derivative of this part, plus, and then the derivative of this part, well, I got a chain rule, 1 over for this natural log, times the derivative of the stuff on the inside, which is 0 plus 1 over x. So I get something like this, which isn't quite what we want. We want to solve for y double prime, so I could multiply both sides of the equation by y prime, but y prime is x to the x times 1 plus the natural log of x. So I copy this here, and that has to get multiplied by this entire thing that I have above, so 1 plus the natural log of x plus, let's see, maybe I'll write this term as 1 divided by x times 1 plus natural log of x. Get to here. And then what I'm going to do is recognize that I have this 1 plus natural log of x in the denominator here. Let's see, what form am I trying to end up with? I'm trying to end up without one of those in the denominator. So maybe I'll take this 1 plus the natural log of x and sort of distribute it through. So what I could do is take this and multiply it by this entire thing here to get 1 plus the natural log of x squared. So that's this times this. But then I still have to multiply it by this thing. So I get 1 plus the natural log of x divided by x times 1 plus the natural log of x, which simplifies to x to the x times 1 plus the natural log of x squared plus this 1 plus natural log of x and this 1 plus natural log of x cancel. I get here. So my second derivative is this, which I think is exactly what I was supposed to come up with. Yep, that looks pretty good. And now you could find the third derivative if you were so inclined. And you'd run into the same problem. Well, you might get kind of clever here. You could just take the derivative of both sides of the equation immediately. So maybe I'll show you another way you can do this, because you know the derivative of x to the x power. Right, we figured that out. We figured it out a few times, in fact. It's this thing right here. So what I could do is just use a product rule and say it's this times this. Or I could take another natural log and do things that way. So I don't know how people will choose to do this, but one way you could do it is you could say y triple prime, and I suppose this way that I'm about to show you, you could have done up here as well, is equal to, this is f, so f prime, maybe I'll say, I don't know, product rule, playing the role of f is x to the x power, playing the role of g is the rest of this stuff, so 1 plus natural log of x squared plus 1 over x. And then f prime, well, I know that from up here. That's x to the x times 1 plus the natural log of x. And g prime, well, let's see, I'd use a chain rule on this part, so I'd bring that 2 down in front, 2 times 1 plus the natural log of x. But then I wouldn't be done. I'd have to multiply that by the derivative of the inside, which is 0 plus 1 over x. And then to take the derivative of this term, this is x to the negative 1 power, so I bring that negative 1 down in front. That makes this negative. And subtract 1 from the exponent, it becomes negative 2, which I guess I could write like this. And so if I take all these pieces and put them together, I got f prime, which is x to the x times 1 plus natural log of x, times g, which is 1 plus the natural log of x squared plus 1 over x, f prime g plus g prime, which is 2 times 1 plus the natural log of x times 1 over x minus 1 over x squared times f, which is x to the x power. So there's my third derivative, one way to get there. And so all that's left now is to do as much algebra as you feel like doing. Let's see, I think I'm going to start by cleaning up this side. So I'll leave, actually there's an x to the x in this term and an x to the x in this term. So maybe I'll factor out that x to the x and create some big, I need more room. So what I'm going to do is point this thing way the hell down here. And I'm going to say, all right, I got two terms. There's one, there's the other one. They both have an x to the x in them. So I'm going to factor out that x to the x. And then what I have left in this first term is I have a 1 plus natural log of x that needs to be multiplied by, and then I got a 1 plus natural log of x squared plus 1 over x. So I can close this up, but leave this one open. And then in my next term, so all of this stuff over on this side, I could get a common denominator, I suppose. I don't know if that really helps. Actually, I don't think it does. So I'm going to write this instead as 2 over x times 1 plus the natural log of x minus 1 over x squared. Get something like this. And from here, I don't know how much more you want to do. I mean, simplified is kind of a subjective term. I like the idea of getting all my 1 plus natural log of x's together. So I suppose I could take this and distribute it through. So that would give me 1 plus the natural log of x cubed plus, and then this 1 plus the natural log of x thing divided by this x right here. So now I've distributed this to these two terms. Maybe I'll do something similar here. This would be 2 of these 1 plus natural log of x things divided by x minus 1 over x squared. And the advantage now is I can put these guys together. They have the same denominator. Well, that's not x squared, that's x to the x power. Sure. X to the x power times, and then I have this 1 plus natural log of x cubed thing, plus 3 of these 1 plus natural log of x over x things, minus 1 over x squared. And I don't know, you can go on as long as you want. You could expand this out and try to combine like terms. I don't think I'm going to. I think I'm going to leave this so it looks just like this. I think I'm going to go ahead and call this good. So maybe I'll write or dot 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 to show that you can rewrite it a million different ways if you feel like it. But there's a few answers. I'll call this good.